This is How Does Everything Work? Quick, clear, simple. Let's begin. Magnets feel like magic. They attract, they repel. They stick to your fridge for years without ever running out of power. But what's actually happening? How do magnets work? To understand magnets, we need to zoom in, way in, down to the level of atoms. Every single atom in the universe has electrons. These electrons don't just sit still, they spin. And because they spin, they create tiny magnetic fields. Think of every electron as a microscopic bar magnet with a north pole and a south pole. Most materials have electrons spinning in random directions. One electron points this way, another points that way. All their tiny magnetic fields cancel each other out. No order, no magnetism. But in some special materials, like iron, nickel, and cobalt, electrons can line up. When many electrons spin in the same direction, their magnetic fields add together. This creates a domain, a small region inside the metal where billions of electrons are aligned. A single domain isn't very strong, but when millions of these domains align in the same direction, you get something powerful, a magnet. That's the secret. Magnets are made of aligned electrons. Now let's explain the classic magnet behavior. When you bring two magnets together, north faces south, and south faces north. Opposites attract, similar poles repel. Why? Because magnetic fields are like stretched rubber bands. Opposite poles pull their fields together, same poles push their fields apart. Magnets are just the organized version of something every atom already has. But here's the part most people never learn. Magnets don't run out of power because electrons don't stop spinning. Their magnetic fields stay as long as the internal domains stay aligned. So why do magnets sometimes weaken? Heat. If you heat a magnet, you give all those electrons energy. They start spinning in random directions. The domains lose alignment. The magnet loses strength. This happens at a specific temperature called the Curie point. Heat destroys magnetic order. Another question. Why do some metals stick to magnets but others don't? Because only certain atoms allow their electrons to align. Iron, nickel, cobalt, and a few others are ferromagnetic. Aluminum, copper, and gold, their electrons won't line up. So no magnetism. Magnets can also move electricity. When a magnet moves near a wire, it pushes electrons inside the wire. That's electricity. This is why electric motors work. Electricity creates magnetism, and magnetism creates motion. It's also how generators work. Motion creates magnetism, and magnetism creates electricity. Magnets and electricity are two sides of the same coin. They are both expressions of one force, electromagnetism. So how do magnets actually work? Magnets aren't magic. They're the result of billions of electrons spinning in sync, creating invisible fields, pushing and pulling the world around them. Magnets work because the universe has a built-in force that loves order, loves alignment, and loves causing strange, invisible effects we use every day. If this helped you understand the world a little better, tap subscribe. There's a lot more to learn, and we're just getting started.